Okay, now I'm recording. Today we are doing section 8.3, trigonometrical functions. Trigonometrical equations. So what does that mean? It means we have those trigonometric functions. Now we should solve some equations related with them. So, okay, this is my document camera. Before we do this section, we first have to aware of those common values, because most of the values we want to solve here are related with common values. So if you know what are the common values, then you almost know the answer. Okay. I have a blank worksheet. I have one with my written notes on. I want to rewrite. So first of all, the most important thing today is review what are the common values. Okay. How many common values we have? We have 0, we have pi over 4, pi over 6, pi over 3, pi over 2. That's it. Those are the most fundamental ones. All others are derived from them. So let's go to our canvas. On the homepage of our canvas, I post the most important graph of our class for the whole semester. So this is our homepage of the trigonometric functions. If you click in a canvas, you see this graph. Okay, this is the most important graph of our semester. That's why I put it here. We don't have so many common values. We just have pi over 6, pi over 4, pi over 3, pi over 2. Okay, and all the x coordinates corresponding to the x coordinate. Oh, sorry, all the x coordinate corresponding to cosine, and all the y coordinate corresponding to sine values. Then if you flip to this side, all the angles become negative. They still share the same x-axis, but flip the sign of the y coordinate, which means flip the sign of the sine values. If we flip to this side, it means they still share the same y coordinate. However, you are just flip the sign of the x coordinate. Okay. So let me write down the common values we're going to use. Sine. Oh yeah. Switch to my document camera. Sine 0 is just 0, right? Sine pi over 6 is 1/2. Sine pi over 4 square root of 2 over 2. Sine pi over 3 square root of 3 over 2. Sine pi over 2 equal to 1. Okay. Using those values, you can derive other values on the coordinates. Cosine 0 is 1. It just goes opposite. So cosine 0 is 1. Then the next value we have is this one. Cosine pi over 6 is square root of 3 over 2. Cosine pi over 4 square root of 2 over 2. cosine pi over 3, 1/2. Cosine pi over 2 is 0. Okay. All other values can be derived from them. If you flip to the other side of the x-axis or flip to the other side of y-axis, you just switch the sign of them. Okay. So let's see how can we solve those equations. First question, solve this equation. This is a very, very common value, right? 1/2. But we also restrict ourselves to this domain. You know, trigonometric functions, they are periodical functions. It repeats itself so many times. However, we just want the solutions on this area. So what would you think would be a good fit of theta, just based on the common values? Anyone have a guess?
Pi over 3.
Very good. Pi over 3. Theta equal to pi over 3. Okay, that's one of our solution, which definitely works. Okay, but beyond this point, we also have other solutions. How to figure them out? As always, we need to refer to the unit circle. Apologize for my terrible drawing, but I hope you can understand this is just the unit circle. Let's say pi over 3 is here. This is pi over 3. Okay, pi over 3. And we know cosine value is just the x coordinate, right? What are the points corresponding to the same x coordinate? If you flip to this side, you see this angle also shares the same x coordinate, right? So what is this angle? It's negative pi over 3. So negative pi over 3 also works. During one period, those are the only values which would work, right? Just in one period, because we only have 2 points corresponding to the same x coordinate.
So Professor, would you only use pi over 3 or negative pi over 3? You wouldn't use 5 pi over 3?
Very good question. So you can write in my notation. You can also write in the Ernesto's notation. However, we just need to figure out all the values in one period. Then we can add those periods so that all the values would be created. Yeah, all the other values will be created. We have not finished yet.
Okay, thank you.
Thank you. We will get your answer soon. So this would work. And we know that cosine has a period 2 pi. So this point work. If we add 2 pi to this point, it does not work, right? So we are done with this one. How about we minus this guy with 2 pi? It's negative 5 pi over 6. Would this point work? Yes, it also works. If you do such a subtraction, you are going back to this angle. However, the angle is just turns out to be negative because you're making one complete trip going back to self. Sorry. Minus should go this direction. Yeah. Okay. So this point is still in this domain to works. How about we continue subtract 2 pi? No, that wouldn't work. We are going beyond the negative 2 pi, below the negative 2 pi, which is not what we want. Here we have negative pi over 3. How about we add 2 pi? Add 2 pi. Two pi is just six pi over 3. 6 pi over 3 minus pi over 3 equal to 5 pi over 3. Okay? So for this point, it also works because it's also in the domain and we add 2 pi to it, so it has the same cosine value. For this point, how about we subtract 2 pi, just like we did here? No, if we subtract 2 pi, we go below this negative 2 pi value, which does not work. So in this way, we figure out all the values which would work on this domain. They are here, 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 here. Oh, I think I made a mistake. So this is negative 5 pi over 3. Okay, 5 over 3. Anyone has any question on this one? Okay, so this is just an example question we are going to do today. Every other question almost follow the same pattern as this question. Let me write down the general procedures. First, you find all fit values within one period. Okay, you find all fit values within one period. Then create more solutions by adding or subtracting periods. Note all values have to be in the restricted domain. That's it. So that's all what we need for today's class. Two procedure. Find all the fit values in one period, then create more solutions by adding or subtracting the periods. All values have to be in the restricted domain, just like we did here. First, we find all the values fitted in one period, which are here, here. Then we add or subtract all the period, which is 2 pi, to create those additional values. And they also have to be inside this restricted domain. And we got all the solutions. Okay, any question on this one? I tell you, all other questions today are following exactly the same procedure. Okay, if nobody has any question, let's just continue. Solve the equation, the same equation, find all the solutions. We find out those solutions in one period. Okay. What does that mean for all solutions? It means we do not have such a restriction here. All the values can work. So what are the odd values can work? Just every time it adds 2 pi, okay? That's it. That's
Professor,
what it means.
wouldn't
Yes.
it be plus or minus 2 pi?
Very good question. The trick is here. When we are saying integer, we mean 0, 1, 2, 3, blah, blah, blah. However, we also mean -1, -2, -3, blah, blah, blah.
Ah, okay.
Okay. Negative integers are also integers. So we do not need to write a minus sign here because k can be negative. That's just, if you're adding a negative number, you are just subtracting, which is equivalent with such a notation. Okay? Thank you for asking. Anyone else has any question? Okay. Again, pay attention to these steps. We are strictly follow those steps. If you follow those steps, today's class will be super easy for you. Okay. Just 2 steps. Question 3. Solve this equation. This seems to be complex. However, we can still figure things out. We want to find theta. We don't know what is theta. Instead, we can find what is sine theta. So if we find sine theta, we can just do what we have done here, then go back to theta. So how do we find sine theta? We first move square root of 3 to the other side. Then this square root of 3 become negative. Then divide both sides with 2. That's it. You get a sine theta. Okay, sine theta is a negative value. We don't know what it is. Again, if you don't know what it is, refer to the common values. So for those values, which one seems to be most related with our question 3?
It's going to be that pi over 3.
Very good, very good. Thank you, gentlemen. It's this value. However, this value gives you a positive square root of 3 over 2. It's not a negative. So again, we turn to our unity circle for help. Our unity circle is like this. Previously, you have positive ones, positive pi over 3. And again, the sign value corresponding to the y coordinate. If you want to get a negative one, just flip to the other side. Okay, so this will become negative pi over 3. I apologize, my writing is too small here. Let me draw a bigger circle. Just make this pi over 3 bigger. Okay, now I hope it's clear. Now it's clear enough, right? Forget about this circle. Okay. So look at this angle. We have negative pi over 3. So we find one value which would work in one period. Okay, we find one fit value within one period. However, unfortunately, within this period, this value does not fit into this domain restriction. Okay, theta has to be between 0 and 2 pi. That's how we initiate our second step. create more solutions by adding or subtracting the periods. All values have to be in the restricted domain. This value is not in the restricted domain, but don't worry, let's just add one period so that this value would fall into this restricted domain. If you add 2 pi, this is 6 pi over 3, so which eventually give you 5 pi over 3. Okay, this fit into this domain. But is that all of our solutions? Did anyone notice I missed something? Missed some more solutions?
Yeah, wouldn't it be 4 pi over 3?
I think you made a guess in the correct direction. However, the value is not so. Okay, let me elaborate a little bit. Again, all the sign values corresponding to the y coordinates. If this point has such a y coordinate, then on this side, just flip to this side, this point also shares the same y coordinate, which means it shares the same sign value. Okay. And what is that? It is. So this would become this is pi over 6. This is also pi over 6. Together you have pi over 3 here. So you are subtracting another pi over 3, which is eventually get negative 2 pi over 3. Okay. However, again, we find one fitted value which shares the same sign value. It is not in the restricted domain. We need to add the periods or subtract periods. This is positive, so we cannot subtract anymore. So let's add a period. So this is 6 pi over 3. Together you have 4 pi over 3. Wow, Ernesto, I was wrong. I was wrong. You're right. 4 pi over 3. Thank you very much for pointing that out.
No problem, Professor.
Thank you. I really appreciate those outspoken people. I really like them. Okay. Great. So in this way, we figure out all the values which would work, which are here, here. Okay. That's it. Anyone has any question? Again, before we turn to the next page, let me reiterate this. Find all the fitting values within one period, add more periods, subtract more periods to create all the possible values in the restricted domain. That's all what we are learning in today's class. Okay. Question 4. Solve this equation. However, this time we have additional difficulty. We have 3 times theta. We don't know what is 3 times theta. So what should we do? Don't worry. Every time, if you don't know anything about it, just treat this as a one thing. Okay. How about we treat this as our alpha? Set alpha equal to 3 theta. Okay. If you don't know what is theta, don't worry. Just set using one Greek symbol to represent everything. So this becomes sine alpha minus 1. Once we figure out alpha, we just divide by 3, we get theta, right? So how do we figure out this one? -1. We still don't know what is -1 is. Okay, refer to our common values. Look at the sign values. Which one seems to be most likely to relate it with our -1?
pi/2.
Very good. Because we have a +1 here, it seems to be most related with -1. Okay. However, this is +pi/2. Again, let's draw the unit circle. pi/2 is this terminal point, right? All the sign values corresponding to the y coordinate. In order to get negative sign values, we have to go to the negative side. So it must be here. Okay? So in other words, it's -pi/2. That's just one value within one period. Does it have other points in the same period? No, because it seems to be the only value which has a y coordinate -1. Okay, we cannot find other values with a y coordinate -1 in the unit circle because this is the lowest point already. So let's just set alpha to be -pi/2. However, we are looking for all solutions, which means we should add all the periods possible. Okay, k can be negative here. So that's why we're just adding this 2k. Are we done yet? No, we are not done yet. We just figured out our alpha. We have not figured out our theta yet. But figuring out our theta is a piece of cake. Alpha equal to this guy, which means theta equal to this guy. 3 theta equal to that guy. If you divide both sides with 3, what do you get? You get this value. That's it. Anyone has any question? Anyone has any question?
So when it's asking for all the solutions, the answer would be that bottom part would be theta is equal to -pi/6.
Very
Right.
good.
Okay.
Yes. Let me circle the final solution. Okay. That's it. No more fancy technology. We got all the values in this way. Anyone has any question on this one? Okay, let's start on the 5th question. As I said, today's class will be very simple, just 2 steps. First step, find a solution in one period, then add all the periods or minus all the periods to get all other solutions. We found all the solutions. And all solutions look like this. However, look at question 5. Still the same question. However, we are only restricting ourselves to be within this period, this 0 to 2 pi. That's our restriction. So we should find all the possible values which fall into this category. How about -pi/6 plus 2 pi/3? Let's k to be 1. Would this value would work? This is -pi/6 plus 4 pi/6, which is 4 pi minus pi, 3 pi/6, which is pi half. So this value would work because it is in the restricted domain. Okay, Let's try to set this k to be 2 to see whether it works or not. If that k is 2, you are just adding 4 pi over 3. This is 8 pi over 6. 8 pi over 6. Let me just write the answer. 7 pi over 6. Great. Still inside this restricted domain. So this point would also work. How about we add 2 pi over 3 more? Would that work? If we add 2 pi over 3 more, what are you getting? This k is 3, so you're adding 2 pi. Two pi is 12 pi over 6, so this is 11 pi over 6. This point would also work because it's also inside this domain. How about we add, we set this k to be 4? Would that work? No, if you set the k to be 4, let's see what you get. (15 pi over 6. 15 pi over 6, which is greater than 2 pi. You are going beyond the domain, so this point would not work. Okay, cross this out. In this way, you figure out all the values which would work. Those are 3 values. Just set k to be 1, k to be 2, k to be 3 to see if they're in the restricted domain or not. That's it. Anyone has any question?
For the third one, what did you plug in for k in order to get 2 pi?
Very good. So here k is 1, here k is 2, here k is 3. You just try everywhere until it ran outside the domain. If k is 3 here, 2 over 3 times 3 is 2. So eventually you have 2 pi. Okay, did I answer your question?
Yes, that did. Thank you.
Thank you for asking. That's it. Anyone has any question before we continue? I said today's class is super easy. You just solve all the equations in this way. Okay. Question 6. Solve the equation like this. Again, the restricted domain is here, okay? This is very complex. I hate complex stuff. Let's just simplify. Use an alpha to denote everything here. What you are doing? So you are doing tangent alpha equal to 1. We don't know what is tangent alpha equal to 1. So let me write down a few key values of tangent function. Tangent 0 is 0. Tangent pi over 6 is square root of 3 over 3. Tangent pi over 4 is 1. Tangent pi over 3 is square root of 3. Tangent pi over 2 do not exist. Okay, because undefined. Does that clear to you? Anyone has any question about these values? So if you are not familiar with those values, I hope you just refer to the sine and cosine values, because tangent is just created by sine divided by cosine, sine divided by cosine, sine divided by cosine, sine divided by cosine. Okay, if you do such a division, you will get those values. Okay. And the last value do not exist. This was because if you have sine pi over 2 divided by cosine pi over 2, you got a 1 over 0. Anything over 0 do not exist, or you can call it undefined. So that's why they do not exist. Okay, so now you have those common values. Which one seems to be fitting into this equation? Hurry up, tell me the answer.
Be
Pi over
tan,
four.
yeah, pi over 4.
Okay, great. I see people talking over each other, giving me the answer. Thank you very much for those people. So then pi over 4 is just 1. Okay. But we're not finished yet. This is just the value in one period. Okay, this is just the value in one period. We have to create for all the periods. And we know tangent function has just a period pi. So if you're adding all the periods, just adding k pi. That's it. This is a general solution for alpha, but we are not done yet. We need to find theta. Our final step is restrict some domain. Okay, before we do that, we find all the possible solutions. If you move to this side, pi over 4 minus pi over 3 plus k pi. This is, what is this? Negative pi over 12 plus k pi. I apologize, I have to go back to here for more space. So if you multiply both sides, this is just pure algebra. Theta is negative pi over 6 plus 2k pi. Okay, does anyone has any question how we get this one? Okay, great. So now we figure out all the possible k values so that theta is in the restricted domain. How about let's set k to be 1? If k is 1, this is 12 pi over 6. So together you have 11 pi over 6. That's it. Can we add more k? Can k be 2? If k be 2, you are adding 4 pi. 4 pi definitely go beyond this restricted domain. Can k be negative 1? If k is negative 1, you are minusing 2 pi, so this is go below this restricted domain. So those two values would not work. Okay, so this is the only value which would work. Okay, I circled the solution here. Anyone has any question? Today's class is going through incredibly smoothly. We only have 2 questions for today's class, and I think we can finish them very quickly. Okay. Okay, just like playing video games, you start from something easy. This looks easy. This also looks easy. Then gradually you are increasing your level of difficulty. This seems to be hard. You are using quadratic functions. This seems to be hard. However, we can always find a way to convert something hard into something easy. Okay. Think about this. We have sine and cosine. We don't want so many diversity here. We just want one single unknown variable so that we can solve everything easily. So how can we convert this sine squared into something just in terms of cosine? I'll give you 1 minute to think about it. The first one who came up with that idea, I will really appreciate that person. Okay, we learned this before, how to convert sine to cosine. Just take your 1 minute and think about it. We have plenty of time during today's class. Think about it. How to convert. Let me write down.
Could it be that if we know that sine squared plus cosine squared is equal to 1, could we do cosine squared minus 1 is equal to?
Excellent. Ernesto, you should be my teaching assistant for this class. Thank you.
I just remembered that equation. That's the only reason.
And
why.
I will pay you Bitcoins. I'll pay you Bitcoins. Okay, I'm just joking. Bitcoins are too expensive. Right now, they're like $40,000 of 1 Bitcoin. So I cannot pay you Bitcoins. But you give me the right answer. The hint is this Pythagorean theorem. Okay. That's all what we need. So if you move this cosine squared to the other side, what do you get? Sine squared theta is just 1 minus cosine theta. That's it, right? Good. So you convert sine squared into something with only cosine. So let's use this rule to convert everything into cosine. If you do such a conversion, what do you get? Okay, so now you have this equal to this. You only have cosine left. Cosine seems to be a troublemaker. How about we just use y to represent it? So that things will look easier. Okay, just use it, y equal to cosine theta. So what do you have? 3y plus 3 equal to 2 minus 2y squared. Move everything to one side, to the left side. 2 move to this side, you get plus 1. 2y squared move to this side, you get 2y squared. That's it. We're done with it. Just in terms of putting into a quadratic form. However, we're not done with solving this y and figure out what is the cosine theta. So remember what you learned from college algebra. Factor this. If you do this factorization, it should look like something like this. Okay, if you do not know how to do such a factorization, please review a college algebra or simply go to YouTube. Type into the keyword how to factor a quadratic equation. Okay. So I just assume you know how to do this. Also stop me if you do not know how to do this, factorization. Feel free to ask me questions. So once we've done this, we can solve this y equal to -1/2 or -1. Those are two good values. So going back to cosine theta, we set cosine theta to be y. So cosine theta is -1/2 or -1. So what is theta? Just for this -1/2, we did something very similar before. We figured out 1/2, but we haven't figured out what is -1/2. Yeah, let's figure out what is -1/2. Again, we turn to the unit circle for help. I think that I'm running out of space here, so let's write it down here. So in order to figure out what is cosine -1/2, let's draw a unit circle. Okay, I refer to the most important values. Okay, I put them on the same area so that they work as a reference. Okay, we don't know what this is. Just look at those cosine value. Which one seems to be most related with it? Okay, seems to be most related with this value. Which one?
Pi over 3.
Very good. Pi over 3. Okay, so let's mark pi over 3 on the unit circle. I mean, this is a terrible unit circle. But just imagine, this is a beautiful unit circle. And this angle is pi over 3, which satisfies cosine theta equal to 1/2. However, we have not reached the solution yet. We need a -1/2. So cosine value corresponding to the x coordinate. You have a -1/2. So what should be a good x coordinate corresponding to a -1/2? We just flip to the other side, find another point. If you flip to this side, what do you get? So this will be also pi over 3. However, this bigger angle will be 2 pi over 3, right? This bigger angle, 2 pi over 3. It's getting rough here. Does anyone has any question about this bigger angle? How get we 2 pi over 3? Okay, so let's just continue. It's getting 2 pi over 3, and it's here. That's a great value. But is this the only solution we have? No, because on the other side of the unit circle, there will be another point which shares the same x coordinate. If you flip to this side, you will also get 4 pi over 3. I'm ignoring the details. I just tell you the answer. Flip this angle to this side. This will be also pi over 3. So together you have 4 pi over 3. Okay, 4 pi over 3. Those are good values. But are they all the values in the restricted domain? Can we add 2 pi or minus 2 pi to any of them? Unfortunately, we cannot. If you add 2 pi or minus 2 pi to any of them, for example, this one, you are going beyond the restricted domain. So you are going beyond the restricted domain. That does not work. How about we add or minus 2 pi to the value corresponding to this one? So what is the value corresponding to this one on the unit circle? Cosine theta is -1. Only this point, right? Only this point. Only this point. This is the only point on the unit circle which has an x coordinate of -1. So what is that point? That point is pi. Okay, we get one solution from this origin. The last step is add all the possible periods. How about we add pi? We add pi, we get 3 pi. We add 2 pi, we get 3 pi. We go beyond this domain. If we minus 2 pi, we also go below this restricted domain. That's it. So that's all for our solutions. Okay. That's it. Anyone has any question? Again, I cannot emphasize how more important this unit circle is. I would say 80% of this semester's knowledge are on the unit circle. 80%. If you know how to handle the unit circle, you get an A in this class. It's just that easy. Okay, any question before we continue? Okay, we still have 20 minutes at the end of this class. Instead of me lecturing to get this done quickly, how about I give you 5 minutes? You guys start working on it. Okay, just try to follow my steps. Just try to follow my recommendations. Okay, fit the fit values within one period, create more solution by instruction. Okay, that's it. So take your 5 minutes and we will discuss it 5 or 6 minutes later. Start working on it. Feel free to ask me any question. This is our last question of today's class. We're done with it. Okay, so let's go back to this question. Does anyone get any solution for this one?
Would 5 pi over 4 be one of them?
Yes, great. That's one of the greatest solution. What else?
Would pi over 4 work?
Yes, pi
Oh,
over
yeah,
4.
pi over 4. My
Yeah.
bad. Negative 3 pi over 4 then?
Unfortunately, that
Or-
may not work.
Okay.
Is 5 pi over 4 one?
Very good. 5 pi over 4 also work, but I would not write it down here because I will show you all the possible solutions. Okay, so let's do it. Tangent squared theta equal to 1. Wow, such a complex question. What does it mean? It means just y squared equal to 1. Okay, if you set tangent set y equal to tangent theta, it just means y squared equal to 1. So what is y? You can solve y equal to 1 or negative 1. That's it. What if y is 1? What do you get? You got tangent theta equal to 1. So what can theta be? Theta is,
Yeah, it'd be pi over 4.
yes, that's just one solution in the one period, right? Just in one period, you got such a value. However, we need to add the periods, so which is k pi. Okay? Anyone has any question how we get this part? That's for tangent theta equal to 1. What if tangent theta equal to negative 1? Just in the period, you got negative pi over 4. Just in one period. Okay? Any question? And again, you should add the periods. K into 2. That's it. We got all the solutions because we are not restricting ourselves to anywhere. So we just use k pi. To sum up, theta equal to plus or minus k over 4 plus pi over 4 plus k pi. K into 2. That's our solution. Okay, anyone has any question? Okay. The next page has nothing. So we are done with section 8.3. Okay, do not go. Let me take attendance. Do not go until the end of the class. Stay here until the end of the class. I need to take attendance, and feel free to ask me any question. And don't forget that this week, Thursday, we still have a quiz. Almost every Thursday, we are going to have a quiz covering the previous class, a previous week's class. Okay, so let me tell you what are the. Do not go. I have not taken attendance yet. I heard somebody left. That guy must be making mistakes. Okay, so let me tell you what is on this Thursday's quiz. You click on the module. Every week we are covering what we done in the previous week. Previous week we did section 8.3. That is going to be on our quiz. But that's just one section. We also need to cover one extra section. So we go back, find section 8.1. If you click on syllabus, you will see the same thing. Okay. So we were supposed to do 8.1. However, we did that in before. So we did quickly and we finished that. However, we have not given any quiz covering 8.1. So in short, this Thursday, we're covering section 8.1, 8.2 on the quiz. Do not go until the end of class. I have not taken my attendance. And feel free to ask me any question. And as I mentioned, the best strategy is review your lecture notes and your books examples. I'm just changing the numbers from there. Okay. For example, if this one tangent theta equal to 1, I may change it from 1 to 3. Okay. This is just my technique to examine, to encourage you guys to review what we learned in class and read the book's examples. Also definitions. Okay, do not go. Stay here if you have any question. Okay, we reached the end of class. Stay here if you have any question. Otherwise, see you on Thursday. Be prepared for the quiz, please.
Thank you.
Thank you, Professor. See you Thursday.
Thank you, Professor.
Bye.
you.
Bye.
Thanks, Professor. Have a good
bye.
day.
Goodbye. Thank you.
Thank you.
Goodbye. Hey, Luciana.